test.
Okay. So let me try to introduce ourselves and describe who we are and why we're here. Maybe we just entered the wrong door again today. Two guys from a shoe manufacturer company. Just a second. Yes, my name is Vitalii, and I am working as a senior software engineer at Echo, and George is the lead platform engineer at Echo Shoes. Echo manufactures and sells high-quality leather shoes and other leather products. Echo is a Danish company with a global footprint, having over 2,000 stores. Every minute, we are selling 30 pairs of shoes around the world. We have a really set of really awesome solutions for business problems we have. We have omni-channel fulfillment that fulfills e-commerce orders in real time. We have solution for real-time optimization of returns of shoes. We have end of season discount optimization and intelligent fulfillment of stores and warehouses. All of this internal solution that we have, we need to deliver the right product in the right place and in the right time. For instance, omnichannel fulfillment service that we have saves more than 2 million euros saves more than 2 million euros in a year, which is a profit of using this solution for fulfillment. Another example is intelligent auto replenishment. It creates almost 17 million decisions and saves more than $2 million in a single region. It's the system works full. The system is fully automated, so people can only configure the behavior of the algorithm. Everything else is done by the intelligent auto replenishment system. Nothing of that could be possible to do without data. That's why we created our in-house open source data streaming framework. You can use QR codes to get access to GitHub repositories. This framework works as a Kubernetes operator, but not really standard operator, but the Kubernetes operator that can be extended by plugins. So we can create a different plugins for different data sources, like database, like REST API, JSON files, and merge them in the Iceberg tables. I will tell in a short how it works. So you can see we have here the YAML file that defines the streaming entity. We have the operator that watches for those YAML resources, custom resources in Kubernetes cluster, and we have this operator creates a Kubernetes job that has no deadline and runs the pod containing Zayo streaming app. Let's deep dive a bit inside the pod. You can see that this Zayo streaming app pulls data from source, converts it to format that can be written to the Iceberg table, writes data in S3 storage, and uses Trino to perform a merge into the target Iceberg table. as you can see, the REST catalog is in the center of this picture, which we use it as entity discovery service. We use it as a transaction management service. And what we need for REST catalog, we need a solution that can handle high operations rate. And now I will let my colleague to tell about solutions that we discovered and what we have as a result.
Thank you, Vitalii, for awesome introduction. So, as Vitalii shown, I'll just quickly bounce to the previous slide. This whole system won't function without data catalog, in this case, Lakekeeper. So why would we choose a REST spec catalog over anything else? Well, first of all, it's actually in the Iceberg world, it's quite hard to find an Iceberg table. In various companies, there are various solutions used. So you can use vendor-specific solutions like Snowflake catalog or Amazon Glue, or something as simple as a GDBC catalog, which just is backed by Postgres database. Or go with the classics. Hive is always there, Hive Metastore. But in essence, in our case, since everything sits in Kubernetes, we are looking for something slightly different here. We're not looking for variety. We're looking for universal product and product that operates like a baseline infrastructure. It's like electricity provider. You don't actually know, or maybe you know, but you don't care who provides electricity to you. You care that if you change it, it works. So here we have our EKS cluster. We have our pods, we have our nodes, great. We have some baking infrastructure that the catalog needs, Postgres database, S3 storage, some authentication that they support. And then if we have Polaris, so we have Lakekeeper, I actually personally do not care as long as I don't have to rewrite my client application 10 times to comply with that catalog API. And this is what the first kind of signal when we actually developed this solution, what told us that maybe REST spec is the spec to go with. Second, obviously, there are some operations that we expect catalogs to perform in this whole setup. First of all, CRUD on our entities. We want to be able to create tables. We want to be able to schema evolve them, to drop them when we don't need them. We want to know where they are. We want to have statistics for them. Because as you saw, we use Trino. Trino relies heavily on table statistics being stored with the table to be able to run your queries efficiently. If you don't have them, it doesn't perform that well. And one of the notorious examples where Trino doesn't work is, for example, is GDBC catalog, because it just doesn't support statistics with GDBC catalogs. Then we also would like an API to actually execute these operations, because we write our own apps that use Iceberg Java API. And sometimes we also write apps that interact with the catalog API directly, and we would like them to behave sort of in the same way. And lastly, if we are sitting in Kubernetes, I would love my authorization and authentication that is built in my service mesh function out of box without me having to set up additional roles or access or whatever that is needed by this specific catalog solution. And then the common transport protocol is also a nice thing. So it's not like Apache Thrift where I have to build a special binary to just connect to the catalog. And here comes the REST spec that was introduced to Iceberg not so long ago. And again, the QR code for you to just refresh what it is. It's essentially just a REST API specification. And these days you can build a server with it, a server code for just based on the Swagger JSON. You can build a client yourself. If you don't like what's on the market right now, you can also just create your own. And that's first wonderful thing about REST spec. You just take the JSON and create code. Second set of features is obviously that when we're talking REST spec for the catalog, we are obviously talking HTTP. We are talking L7. All data and AI apps, majority, they sit on L7 and they brief HTTP. It's the common language for them. You don't need anything else. worst case, you can curl your way out of your problem. And that really makes it very easy for people to interact with your catalog. Second, and here we come also to the point that it's portable, meaning I don't have to rewrite my client code. I don't have to build exotic libraries when I pip install. Famous example, again, I love Thrift. So when you install something that requires Thrift, you have to build the Thrift from source on some systems, and that's just not a great experience sometimes. You don't have to do that with Iceberg REST catalog at all. Second, and other thing is that it's AuthZ native. Again, I have my service mesh. My service mesh looks what route application is addressing and applies authorization rules to it. I actually don't need to set up anything else if I already have a working authorization system, which we do, for example. And if I want, I can add something else, but it also integrates in what I have. And lastly, if I want to scale, I just add more web hosts, and that's it. And the web host proxies my connections and handles all the complexity that the client might throw at the catalog, which in our case is several thousand operations per minute, and no problem with that. In the end, we are hiring, and we have some open source projects that we would like people to help us build. So please check us out. And a final remark for this talk is that we always try to focus on building things that power engineers to do engineering rather than spending time on building useless binaries or whatever else the crazy world outside might throw at them, make their life interesting. So please check us out, and thank you for your attention.
Is there a question? Oh,
yes?
Is it safe? Yeah, it's safe. Okay. Hello. So my name is Almas. I'm from Revolut, and I have a question. Are you satisfying with the current REST catalog in production?
So we actually tried from this wonderful zoo here a couple of solutions, right? So we are a Snowflake customer, so we also we don't use Polaris that in Snowflake, so we tried the open source one. The reason we don't use this one, we did try to use this one, but at that time it was December last year. It didn't support S3 compatible storage, though I found a way to hack it, so it does support it, but it was so hacky we opted out of using it in production. We also tried these options. As I said, with GDBC, there was a problem with query optimization. We were also probably one of the first people who just took Polaris from a cloned Apache Polaris and built it when there was no production build available for it. So it was before version 09 was even officially released. So we went quite a journey there. And there were a lot of problems, and I was annoying people on GitHub a lot with all the bugs we found. Then we found Lakekeeper, and that kind of solved everything we needed. I don't know, probably Polaris also moved towards that because I provided them a lot of feedback with what was going wrong. But I haven't followed the project since February, March approximately. And now I'm super happy. So we have, like, as I said, several thousand operations per minute on the catalog, which is table commits, creations, drops. So this whole system, right, that Vitalii showed, which for each micro batch creates a table and executes a merge. And we have like 5 pods which consume 1 gig of memory, half a gig of memory each, and 10% CPU, and that's all it takes to handle that.
Cool, nice. And I guess the next question is like the classic question regarding streaming and Iceberg, how you handle streaming and maintenance, because there are always conflicts, and we struggle with Hive when like you have Hive logs, and some maintenance operation can block table for a long period of time, which makes impossible to do streaming?
Very good question. And maybe I have a good answer, maybe not, you judge. So Arcane itself consists of an operator, right, and the plugin code. Plugins use the same shared library called Arcane Framework, which is a Zio library. So the whole streaming thing is handled by Zio. Maintenance operations are a separate stage in the stream pipeline that are executed certain number of batches. So they are not executed by the catalog, because otherwise we'll have a conflict. They are executed by the streaming pipeline. And that is configurable by developer. Depending on the source, you can delay the maintenance operation or you can execute it quite often. It's up to you. So for sources that have a lot of small updates, we try to execute it more often. And yes, it pauses the streaming pipeline essentially, because you have to, in Iceberg, you actually have 3 operations. You have optimize to compact your files. Then you need to clean the garbage in your metadata, and then you need to remove the orphan files, right? So, but the whole thing takes even on the tables that are several hundred gigabytes in size, it may take like 5 minutes on our current infrastructure to execute that procedure. So yes, it can hurt some workloads, but in our case, it's not that critical. The 5 to 10, okay, 10, let's say 10. 5 to 10 minute delay is not that critical for products like auto replenishment, for example, because auto replenishment is configured by people who manage their store, the set of stores. So they basically oversee what do we have, and we forecast the demand for our products, and then we try to fulfill the store. So when you come and want to buy your specific size of shoes, specific color, we actually have that in the store, but not too much. And then we just need to have up-to-date inventory data on the moment when the optimization problem is solved. We don't to have it while it is solved, because that would make the optimizer much more complex and we won't be able to solve it to the time we need to send the trucks.
Thank you. And last question regarding performance. So currently we have 500,000 objects in Hive Metastore, and also we struggle with, just some list operations, information schema sometimes doesn't work due to timeouts. And question regarding usage of Lightkeeper. What is the scale? How many objects do you have? And is there some visible performance degradation on these such operations?
So I can tell you a fun story about that. So until Lightkeeper, I think 0.5, which is the version we are on right now, there was a funny bug that I found that it was slowly performance degrading, because it was computing statistics, like how many tables we have. And at some point it showed that I had like, what was it, 600,000 tables in the storage, while in reality I had 500. So I was like, what's going on? So we raised that, and Christian fixed that really quick. Since then, there was no problem. In essence, we have like around 600 active tables, and then several thousand are created and dropped every time. And we don't see any problems with that. If you're curious what we use behind, I think it was actually shown here, right? Sorry. What was it? In my slide right here. So we use, this is correct icon. This is Aurora. It's not the cheapest solution, but the reason we use it because it's very easy to connect it. Aurora in this case is auto scaling, and then it has read and write replica, and Lightkeeper is, at least when we started using it, can't say now, at least when we started using it, it was the only solution that supported using both write and read replica. So it can actually load balance your database, which was the problem for Polaris at that time. So with a workload with Road, it would just clog the database, and then you will have 100 CPU there. And the only problem was to throw money at it. And our approach is usually try not to throw money at problems. So this ability of the catalog to split read to write was super neat, and it solved all the performance problems with the database. And yeah, as I said, it's 5 application pods right now, which serve all the requests that are Trino is issuing, because also these two several thousand operations, that's just from Arcane, so from our active ingestion pipelines. There are also people running ad hoc queries on that system which use data catalog. There are also data engineering pipelines that are executed more like in a scheduled fashion. So there can be times when this is actually highly active system. But since we moved to Lakekeeper and we did some work with them, it didn't work flawlessly from the start, but to version 0.8.5, I have not actually checked what's going on in this world for several months. I was so happy.
George, Vitalii, thank you very much, guys. Applause.